Good day everybody, we have an interesting question. So foremost, let me draw the figure. Okay, now we are asked to find the shaded region. Now which is the shaded region? We want this region. Okay, this region is required. We have this length. Let me write this out down. AB, CD. AB or AD is given as 5 units. AB is given as 10 units. Okay. So O is the center. O, center of semicircle. So you can pause this video and you can try this question out. So when we come back, we can learn how to solve this question. Okay, I hope you all have got the solution. So let us get started. Now ABCD is our rectangle, and we are clearly given O is the center. So what I'm going to do is I am going to actually split the rectangle. So I'm going to split the rectangle here. Now do you see what figure the rectangle is creating when I split it? Right, I'm getting a square. Now before I could proceed on, what I wish to do here is I would like to give the formula for the required region. So let me take this point as E and this point as F. This particular point is F. This part is required, right? This region is required. So for that, we need to isolate this region. We have to get this region. So this is the challenge here. So what I'm going to do is to get this region from the point F, I'm going to connect to O, right? So this will also be 5 units. Okay, so what do you see here? You see a sector here. So if you were to look at the diagram, we need this shaded region. Okay, FDE. The required area is FDE. And how do we get that? Now you see here, this is a right triangle. Now from the area of triangle BCD, I'm going to take away this particular portion, FEB, right? You see that FEB? I take away the area of FEB, and following that I would have to take away the area of ECG, right? so this is going to be removed also, area of ECG. Okay, and the resulting area would be FDE. I hope this point is clear to you. So foremost, what we are going to do is, this is the rectangle. I am actually splitting the rectangle. So clearly we see, what do we see? We see that OBCE is a square such that OB is equal to BC is equal to CE is equal to OE or EO, which is equal to 5 units. So the area of the square OBCE is going to be side multiplied with side, which is 5 into 5 will give me 25 square units. Okay, now let's go back to the figure. Now you see this is a quarter circle. OEB is a quarter circle. Also we see that OEB is a quarter circle, right? So what is the area of the quarter circle? So area of OEB is going to be pi r squared divided by 4. Now what is the radii of the quarter circle? OB is a radius, right? OE is a radius, so that's 5 units. So this is going to be pi over 4 times r squared. R squared is going to be 5 units, right? So you square it, and that would give us the area of 25 over pi, or 25 over 4 times pi square units. Okay, now since that we have got the area of the quarter circle, I would like to draw your attention back to the figure. So from the square we are taking away the quarter circle, and that would give us the area of ECG. So that's exactly what I'm going to do here. Hence required area of ECG is equal to area of square minus area of quarter circle. So area of square is 25 square units, quarter circle is 25 pi over 4. Okay, and I will name it as A, because we would have to put this ECG right over here. Okay, so let me take this as say 1. So next step is we would have to find the area of FEB. I hope you are watching this. We need this FEB. So to get FEB, what I want to do is I will first find the area of the sector. You see this OFEB. Okay, I want to get the sector OFEB. Right, now before you could get OFEB, you will have to make this following observation. Now this is clearly the radius of the semicircle. This is also radius of the semicircle. So clearly OFB will form a triangle such that OF and OB are going to be of same sides. So this means OFB is an isosceles. So if I were to take this as alpha and this as alpha, then this central angle is going to be 180 minus 2 alpha. Okay, so that is a very important observation that enables us to get this angle. This is critical. So I'm going to start off like this. Area of the sector. Area of sector OFEB. So let me show that to you again. OFEB, the sector. The radii for the sector is 5 units and the angle at O is 180 minus 2 alpha. Okay, so area of the sector has got a formula, theta over 360 multiplied with pi r squared. Our theta is 180 negative 2 alpha divided by 360 multiplied with pi times 5 squared, so 5 into 5. I'm writing it like this. Now 5 divides here, 7 5s are 35, 10. 5 times 2 is 10, right? Okay, 72 times is here. So this is equal to 180 negative 2 alpha. I put the 5 here and the pi here and 72. This is the area of the sector. Okay, this is what we have got. So area of OFEB, right? Okay, so let us move on. Now the next step here is we need to get this off. Okay, we need to get this region off. We need to, from the sector, we need to actually take this off. Okay, so from the sector I need to extract this region. So how do I do that? So what I'm going to do is I'm going to take the sector area OFEB. From the sector area I am going to take this triangle, the isosceles triangle's area out. And once I take that isosceles triangle area, this triangle's area out from the sector area, I would be left with FEB, right, which is what is required. So I'm going to write that down here. Okay, required area is FEB, which is got by using the area of sector OFEB, and from that taking away the area of triangle OFB. Okay, fair enough. Now before I could get the area of the triangle, I need two important informations. Okay, so let me use a new sheet of paper. Now what are the two important informations I need? I need to get sine alpha and cos alpha. You will know why. Okay, and also, well, once we get sine alpha, cos alpha, that would be enough for us to extract the value of alpha. Now you will know why do we need these. Now to get that, we need to consider the triangle B and C. Consider the triangle BCD. It's a right triangle, right? So let me draw this triangle for you. So this is BCD and this is going to be the 90 degrees angle. Okay, so now what we are going to do is we will have to obtain the length of the sides. Okay, so clearly I know this is 5 units and this entire length is going to be 10 units. This is okay. All right, that's going to be 10. This entire length is going to be 10 units, right? This is 10 there, so it's going to be 10. So by Pythagoras, so you can state here, since triangle BCD is right angled, we use Pythagoras theorem. So by Pythagoras theorem, we have, so what do we have? We got DC squared plus BC squared is equal to BD squared. So BC squared is 5 squared, BD squared is 10 squared, DC squared is 10 squared, so we need BD squared. So therefore BD squared is equal to 100 plus 25, this is going to be 125. So BD is going to be root of 125. Now 25 multiplied with 5 is going to be 125. I can rewrite this as root of 25 times root of 5, which is going to give me 5 times root 5. This is my BD. Okay, 5 times root 5. So this is going to be 5 times root 5, this entire length. Now, if you were to consider this, if we have taken this as alpha, the angle, the side opposite to alpha is opposite side. This side is hypotenuse side and this side is adjacent side. Now what is sine alpha? Using trig ratio, we know that. What do we know? Sine alpha is opposite side by hypotenuse. So our opposite side is 5. Our hypotenuse side is 5 into root 5, right? Our opposite side is 5, hypotenuse side is 5 into root 5, which is going to give me 1 over root 5. Okay, this is my sine alpha. Cos alpha is adjacent side divided by hypotenuse. So what is my adjacent side? Adjacent side is 10 units. Hypotenuse 5 root 5. 5 divides here 2 times, so you have 2 over root 5. Okay, fair enough. Now we can extract alpha from here also. Okay, so alpha is equal to sine inverse of 1 over root 5. So let me show you that sine inverse of 1 over root 5. Okay, okay, this is the value. So this is alpha is equal to 26.56. Okay, so now we will have to get the area of triangle OFB. Now we know the formula for that. It's going to be half times the sides are OF multiplied with OB times the sine of the angle between them. Okay, the sine of the angle between the sides is 180 minus 2 alpha. Okay, so this is going to be 1 over 2 times OF is 5 units and OB is 5 units. Sine of 180 minus 2 alpha, that's going to give me sine 2 alpha. So this is going to be 5 5s are 25 over 2 times sine 2 alpha. I'm going to rewrite it as 2 times sine alpha times cos alpha. So my 2 gets cancelled over here. So it's going to be 25 times sine alpha times cos alpha. But sine alpha, what did we get for sine alpha? Sine alpha is 1 over root 5 and cos alpha is 2 over root 5, right? So 1 over root 5 multiplied with 2 over root 5. So this is going to be 2 times 25. Root 5 into root 5 will give me 5. 5 divides here 5 times, so I get 10. So the area of triangle OFB is 10 square units. Okay, having got that, let me find the area of the sector OFEB. So we need the sector area, right? So what is that formula given? Sector area is going to be theta over 360 times pi r squared. Okay, having given or having got that formula, my theta is this angle. So it's going to be 180 negative 2 times alpha divided by 360 multiplied with pi. My radius is 5 into 5. Of course, we have already evaluated this. We have got that this value to be as 5 times of 180 negative 2 alpha times pi divided by 72. Right, in the previous case we actually obtained this. So now alpha, take the value of alpha. Alpha is we got the value of alpha. What did we calculate? We calculated alpha to be as 26.56 degrees. Now take that and substitute it here. So it's 5 times of 180 minus 2 times of 26.56 divided by 72. Now we have to evaluate this. So let me show you. 26.56 times 2, that is giving you 53.12. So 180 minus 53.12, you have a pi there, a 5 here and a 72. So from 180 I'm subtracting 53.12, that's giving me 126.88. I divided by 72, that's giving me 1.76. I have to multiply it with 3.14. So 1.76 you multiply by 3.14 and you multiply it again by 5, you get 27.632. This is the area, right? Square units, sector's area. So what is the requirement? From the area of the sector, I take away the area of the triangle, I get FEB, right? So let me use this part here. So area of FEB is 27.632. I subtract the triangle area, which is 10, that is going to give me 17.632. This is what I'm getting. So let me go back to the figure. Now we have already got this region, we have this region also. So we are going to be using the triangle, this triangle. From the triangle we are going to take away this and this. So let's see how to do that. So required area FDE is going to be area. So let me write this down. Area of triangle BCD. From BCD we are taking away the area of FEB, and then we are taking away the area of ECG. Comes the area of the triangle BCD. So area of triangle BCD. What is the area of the triangle BCD? Half times base into height. So what is the base? The base is 10 units and the height is 5 units. So 2 divides 5, you have 25. This is ECG area. So from the area of the square I am taking away. Okay, alright. So pi is 3.14. So let us check what we are getting here. So 3.14 multiplied with 25 divided by 4. So 19.625. Okay. So let me check one more time. 25 times 3.14. This is what I get. I divide by 4 and 19.625. So from 25 you take away 19.625. You get 5.37. Okay, we're taking away all this. Now area of the triangle, we have already calculated this. Area of the triangle ABCD. That's obtained as 25 square units. Now area of FEB. We got that area of FEB. That is, let me get that area for you. So that is 17.632, and we also got the area of ECG. That's 5.375. So it's going to be 25 negative of 17.632 positive 5.375. So we add these two together first. 17.632 positive 5.375. So this is going to be 23.007, and we have to take it out from 25. So 25 minus 23.007, and that is giving you area of 1.993 square units. So this required region FDE, this required region FDE, hence the required area FDE is 1.993 square units. So that's the solution for this question. Please like, share and subscribe everybody. Thank you.